Now, let us discuss triangles on the same base and between the same parallels. Here, let us consider a snooker table with 6 pockets, one at each corner and one each in the middle of the longer side. Using this table, let us see what can we come up with. The top view of the snooker table is shown. Let us draw two triangles ABF and ABD on the snooker table. So, by looking at the diagram, can you tell me what is common in the triangles? They have a common base and also they have a common height, because if we see the boundary of the table, they have parallel lines, and we know that the distance between the two parallel lines is always constant. Therefore, height and base are same in these two triangles. Can we calculate the area of the triangle by just knowing these two parameters? Yes, the area of the triangle is given by half multiplied by base into height. Now, since both the triangles base and height are same, the area of the triangle is also going to be the same. So, from this we arrive at a theorem that states triangles drawn between the two parallel lines with same base always have equal areas. Let us try to prove the same. Consider a parallelogram ABCD whose one of the diagonal is AC. Also, let AN be the perpendicular to DC. From the figure, we see that triangle ADC is congruent to triangle CBA because diagonal of a parallelogram divides it into two congruent triangles. Since they are congruent to each other, the area of ADC is equal to the area of CBA. Therefore, area of ADC is equal to the half of area of ABCD, which is then equal to half of DC multiplied by AN, because the altitude is same in both the triangle as well as the parallelogram. Therefore, area of triangle ADC is equal to the half of base DC multiplied by corresponding altitude, that is AN. Hence, it's proved. Therefore, two triangles on the same basis or equal bases and between the same parallels are always equal in area. Also, its converse is true, which states that two triangles having the same base and equal areas also lie between the same parallels. As many triangles you draw within the parallel lines with same base, you get equal areas. Also, if any two triangles having the same base and equal areas always lie between the same parallels. Let us see how to prove this statement. From the construction, draw the altitudes of triangle ABC and triangle ABD through C and D and meeting the base at E and F respectively. So, the proof is that since CE is perpendicular to AB and DF is perpendicular to AB by construction. Since lines perpendicular to same line are parallel to each other, therefore CE is parallel to DF. Let us write this as 1. Now, area of triangle ABC is equal to the half of AB and CE. That is, area of triangle ABD is equal to half multiplied by AB into DF. Since area of triangle ABC is equal to the area of triangle ABD, which is given, therefore CE is equal to DF. Let us write this as 2. Now, in CDFE, CE is equal to DF and CE is parallel to DF. Since one pair of opposite sides are equal and parallel, CDFE is a parallelogram. So, CD is parallel to EF because opposite sides of a parallelogram are always equal and parallel. CD is parallel to AB. Therefore, that's proved. Therefore, two triangles having the same base or equal bases and equal areas lie between the same parallels. Show that a median of a triangle divides it into two triangles of equal areas. A median of a triangle divides it into two triangles of equal areas. Let us see how we can make use of this median in this scenario. Let us consider a triangle ABC and let AD be one of its medians. Therefore, we are supposed to prove that area of ABD is equal to the area of ACD. Since the formula for area involves altitude, let us draw AN perpendicular to BC. Now, area of ABD is equal to the half multiplied by base and the corresponding altitude of the triangle, that is ABD. Therefore, we get half into BD into AN. As BD is equal to CD, we write half into CD into AN, which is therefore half multiplied to base and altitude of triangle ACD, which implies that this is equal to the area of ACD. Therefore, a median of a triangle divides it into two triangles of equal areas. Now, let us consider a problem. In the figure, AP is parallel to BQ, which is parallel to CR. Let's prove that area of AQC is equal to the area of PBR. From the figure, we see that triangle ABQ and triangle PBQ lie on the same base BQ and are between the same parallel, that is AP and BQ. That is, we see that area of triangle ABQ is equal to the area of triangle PBQ. Let us write the statement as 1. Now, since triangle BCQ and triangle BRQ lie on the same base BQ and are between the same parallel BQ and CR, we see that area of triangle BCQ is equal to the area of triangle BRQ. Let's write this as 2. On adding equations 1 and 2, we obtain area of triangle ABQ plus area of triangle BCQ is equal to the area of triangle PBQ plus area of triangle BRQ. Therefore, area of triangle AQC is equal to the area of PBR. Let us consider another problem. In the figure, ABCDE is a pentagon. A line through B parallel to AC meets DC produced at F. Show that area of ACB is equal to the area of ACF and area of AEDF is equal to the area of ABCDE. The solution for the same is as follows. Triangle ACB and triangle ACF lie on the same base AC and are between the same parallels AC and BF. It can be observed that area of triangle ACB is equal to the area of triangle ACF. Therefore, area of triangle ACB plus area of triangle ACDE is equal to the area of triangle ACF plus area of triangle ACDE. That is, area of ABCDE is equal to the area of AEDF. Also, I would like to cover a special condition which I think might be useful later. So far, we have learned how to play with triangles when there are common bases. What happens when two triangles have different bases? Therefore, let us consider two triangles with different bases. What do you infer from them? The two triangles having the same heights, but they differ in their bases. If you clearly see the diagram, one big triangle is split into two triangles by joining a line. Therefore, the conclusion is, if we draw two triangles by splitting a one big triangle, height of all the three triangles are going to be the same. And when we see the areas of these triangles, it is not going to be equal because they do not have both common bases. But here, the ratio of their areas will be equal to the ratio of their bases. Now, let us see if this condition satisfies or not. Now, taking the ratios of their areas, we get half into base 1 into height, divide the whole by half into base 2 into height. Half and height would be cancelled out because they are common, and the remaining would be their ratio of bases. Therefore, the ratios of area of the triangles ABF and BGF is given by base 1 by base 2. Let's summarize. Triangles on the same base or equal bases and between the same parallels are always equal in area. Area of a triangle is half the product of its base and the corresponding altitude. Triangles on the same base or equal bases and having equal areas lie between the same parallels. A median of a triangle divides it into two triangles of equal areas. Ratio of area of two triangles with different bases are in the ratio base 1 by base 2.